up, guys? Welcome back to Linear Algebra Mastery. Let's go. Jump right into Anki. Flashcard. Oh, why, hello there. All right, no flashcards today. What did we do yesterday then? Well, we finished reading section 3 of chapter 1-3, which was all about matrices and matrix operations. The last two sections which we read yesterday were about, trace. There were two more operations for on matrices. We learned addition, subtraction, multiplication, scalar multiplication, and trace of a matrix. Trace is basically it's the sum of the entries of the main diagonal of a matrix, and a matrix only has a main diagonal if it's a square matrix. If it's not a square matrix, the trace is undefined. Okay. The trace of a matrix is denoted TR, both lowercase and then parentheses. Within the parentheses, you got the matrix, so TR parenthesis matrix symbol parenthesis. Then we learned the other matrix operation was transpose of a matrix, transposing. This is where you basically switch the rows with the columns of a matrix. That's it. I think that's everything. Then we started doing the practice problems from the problem set for 1-3. And so in that problem set, what do we got? Yeah, we did two problems. Okay, trace of a matrix, cool. One thing we forgot. Two things we forgot. First, we got a historical note. What was this guy's name? We learned about who first named or used the term matrix to describe a mathematical object. Okay. Sylvester? I don't exactly know what's his name. But this guy was funny. He got kicked out of, or he fled America because he smacked a student for reading a newspaper in class. He thought he killed him. He was just in shock. Funny story. Arthur Cayley? I don't know how to pronounce his name. Cayley. This guy is the one that developed early matrix operations. James Sylvester, right? Cool. And then the trace of a matrix. Transpose is denoted with an exponential to capital T. So you have the matrix symbol to the power of capital T. That's how you know the transpose. Cool. And a special case for transposing is when you have a square matrix. You basically just reflect the entries over about the main diagonal. Yeah. So now what we're going to do is grade my problems from yesterday and then continue doing practice problems. So I'll be back in a second. All right, we got both problems correct. So now what we're going to do is continue doing practice problems from 1.3. I will talk to you guys in a bit. All right, guys, I struggled and I didn't allow myself to go back in the text to look at how to do these things because that's not how you learn it. You got to just let it fucking piss you off and then wait a day and come back and then be like, that's how of course you do it. Anyway, we solved one fine. We know how to do the multiplication fine. The problem is now doing that like row method. What is it called? Row by row? Row method or column method in order to find a specific row or column of the resulting matrix. That was difficult. I didn't get that. And then the linear combination stuff where you have to express the resulting column vectors in the original column vectors. So linear combination, that's struggling. The row method, the column method, those are both struggling, all three of those. So I'll check how to do this tomorrow, figure it out, and yeah, that's it for today. Talk to you later. See you.